All right, here we go. Final exam cheat sheet. We're going to be covering all 21 of your final exam questions. 21 questions from the final exam. This will cover material all the way across from chapter 1 through chapter 5. What I'll be doing with each of these problems is I'm going to put up a reference number, basically, that will tell you what chapter and section that you can look at further materials, definitions, other examples, whatever you need. For instance, our very first question is going to be referencing chapter 1, section 3. Okay, so you'll see these little pink boxes at the beginning of every problem with the chapter and section reference. I'll make sure I add these also on your final exam document so that you can double check that stuff if needed. Okay, but again, this cheat sheet will be your primary resource for looking at solutions and guidance for how to go through solving these things. Okay, so today we're going to be covering 4 problems from those 21 total. All 4 of these problems will come from chapter 1. Okay, so this will all be based on the functions and exponents unit that we did at the very, very beginning of the year. Okay, what I'll do is I'll show you how the question will be phrased. I'll give you an example problem that will be different than what you will see on your final exam, but it will be structured exactly the same way. It'll just be different numbers, essentially. Okay, so our first problem, the very first problem on your final exam, you are going to be asked to do the following. You're going to be given an equation. You're going to be asked to find the inverse of that equation. You're going to be asked to find the inverse of a given equation. The example I will give you will be as follows. Y equals negative 5x plus 10. Again, you will see different numbers on your final exam, but essentially it will be structured the same exact way. You'll be given a linear function. You may recognize this as an mx plus b type of line if I were to graph it. But you'll be given a linear function as follows, and you're going to be asked to find the inverse of that function. In section 3, the title of this section was inverses of a function. Okay, and essentially what inverse means, if by the way, you need to add any other additional kind of phrasing or descriptions or your own wording and stuff in the margins, feel free to do so. These are your notes ultimately. But in this case, inverse for us is going to mean opposite or other. Okay, what it's essentially saying is that as this is written, this is currently solved for y. How do I know that? Y is by itself on one side of the equal sign. That means that this equation is solved for y. When I'm finding the inverse, I'm going to be solving or isolating the other variable. In other words, what I'm going to be doing here, my goal here is to rearrange this equation to take these objects and move them away from x so that x is by itself and all the other junk is over here on the other side of the equation. And so the strategy here will be to use inverse operations to move these objects away. Okay, so this will be a pretty deep dive into Math 1 material where it came to solving algebraic equations. Okay, so there are 2 objects that really I need to move here. This positive 10 that's being added at the back end and this negative 5 that's being multiplied by the x. Many of you will already know this, but the first object that is the most convenient to move is this added 10. And so how will this 10 move? Since it's being added, okay, I'm going to be doing an inverse operation to move it across this bridge, this equal sign. And the inverse operation here will be to do the opposite of addition, which is subtraction. Many of you probably would not need that much wording to describe what's happening, but that's where it comes from. So I'm going to be subtracting 10 from the right-hand side. Well, in order to make sure I'm not changing this equation fundamentally, I have to make sure I balance the equation. So whatever I do to the right-hand side, I also have to do to the left. So if I subtracted 10 from the right, I have to subtract 10 from the left. And after I do so, over here on the right-hand side, the whole reason I did this inverse operation is that these 2 will cancel. They'll go away. And I'm left with just the negative 5x on the right-hand side. And then on the left-hand side, I would see if I could combine these terms. These will not combine. Y's will not combine with numbers. Numbers will not combine with y's. So in this case, I would be left with simply y minus 10. Using my 2 different colors here. Okay, well, I've successfully moved one of the objects away. I'm not quite done yet because I need to get this x by itself. So the next thing to move has to be this negative 5. It will move differently, though, because it's doing something different to the x. The -5 here is multiplying by the x, so the inverse operation in this case will be to do the opposite of multiplication, which is division. So I'm going to divide by -5. And the reason I do that is because these will ultimately cancel, thus doing the inverse of what it was doing originally. But again, I need to balance this. So whatever I do to the right-hand side, I also have to do to the left. So I need to divide that whole side by the -5 as well. And after doing so, on the right-hand side, I will have successfully isolated x. Let's go ahead and jump to that. So over here on the right-hand side, I will have successfully gotten x by itself, thus solving for it, thus providing an inverse to the original equation. On the left-hand side, I would have this y minus 10 divided by -5. Now, I'm going to deal with this in a minute because there's a way that I can simplify this a little bit further. Technically speaking, I would have finished solving for x. No matter how messy it got on this side, it is officially solved for x. I have found the inverse. Okay, but let me go a little bit further and actually break this down into a more simplified version. Namely, I can take this denominator and put it into both pieces of the numerator. For instance, nothing's going to change here on the right. It's still going to be equal to x. But now when I split up the denominator, my numerator is still y and -10. But when I split up this denominator into both of these objects are going to be divided by -5. Okay, and you'll see why I do this in a second. So let me scroll down a little bit further. Okay, so now in both these cases, I can split these up a little bit better. This actually can end up reducing. Let me write this in a little bit more of a friendly manner. Anytime I divide by a number, that's the same thing as multiplying it by a reciprocal. So I can actually rewrite this as -1/5 times y. All right. And then this can actually reduce. -10 over -5, the negatives cancel, and I'm left with a +2. And this is all still equal to x. So for the record, this result, which is what I'll be looking for full points, okay, this result is the same exact thing as what we got originally. It's just that this is a more split up version, a more simplified version. Okay, and the reason why this version right here might come in handy, why we might prefer this one, is because this actually looks a lot similar to our very first equation that we were given, in that it is linear in nature. In other words, if I were asked to graph this inverse, this looks an awful lot like mx plus b form, so I would have a lot of information about how to graph that result. But ultimately, that is the final answer I'm looking for. Essentially, it breaks down to inverse operations to solve for a variable. And there's problem number 1. Okay, so let's move on. That's our first problem on your final exam. All right, let's move on to number 2. These next 2 problems are both going to come from Chapter 1, Section 4. So just number 2 on your final exam will come from Chapter 1, Section 4. For those that do not remember the title of that section, what did Section 4 cover? It covered properties of exponents. Properties of exponents. We're going to deal with how to simplify exponential type of figures. So what you're going to be asked to do here is you're going to be asked to simplify a given phrase. Okay, it's another way to say like condense or reduce. Okay, but you're going to be asked to do so using only positive exponents. This may sound familiar from Chapter 1. If it doesn't, you're about to see how that's covered right now. Okay, so you're going to be asked to simplify using only positive exponents. So let me jump right to what you will see. So problem number 2 on your final exam will look similar to this. You're going to be given 2 things that are multiplied by each other. Okay, it won't be exactly this, but it'll look very, very similar. Okay, so what we are given here is we have 2 common bases. 2 common bases that have their own exponents. Okay, and they're being multiplied together. Anytime I have 2 common bases multiplied by together, one of the properties that we learned of in Section 4 had to do with what do we do with these exponents. Essentially, what's going to happen here is anytime I have 2 common bases multiplied by each other, I'm simply going to add these 2 exponents together. Okay. And by the way, you see this negative exponent. We're going to deal with that lastly in this case about how to convert this into only positive. But in this case, the simple task here is to simply add up my two exponents. And this is how it's going to be simplified is right here I have two objects. It's going to be reduced down to a single object. And now in my exponents, this 3 and -5, I'm going to add these two values together. Use a different color. There we go. Okay, anytime I multiply common bases, I'm going to be adding the two exponents. So simple enough here. 3 plus a -5 would give me a -2. So I'd have x to the -2 power. Okay, so technically I have done the first task of this question, of this problem. I have officially simplified this down to a condensed object. The problem here is now that I have to deal with the second task. I need only positive exponents, and you'll notice I have a negative result here. Hint, hint, on your final exam, you will also have a negative result after that first step. So how do we deal with negative exponents? So here's where I'll take the time to remind you about like what do negative exponents actually do. Okay, if you are curious about those sorts of things, you can revert back to section 4 notes or section 4 recordings to see more detail on what is done there. But essentially the common mistake is people think that like, oh, I'm just going to multiply by -2. This is an exponent, right? It's not going to multiply. It tells me how many times this object is multiplied by itself. And that's where it gets a little funky because you can't multiply something by itself negative times, can you? Okay. And so a lot of people make the mistake that they think they're just going to get a negative result. Here is what is going to happen. Technically speaking, this as it's written is technically all over 1. We just don't bother writing that, right? Anytime we have a single object, it's technically over 1. We just don't bother writing it because we don't bother writing it, right? It's redundant, right? It's more work. Here's where it's going to come in handy. The way I deal with converting a negative exponent to a positive exponent is I'm going to do a mathematical term called taking a reciprocal. Basically, this x to the -2 is in the numerator. If I want to make that positive, I need to drop it down to the denominator. Had it been in the denominator, that negative exponent, I would move it up to the numerator. Okay, so taking a reciprocal simply takes what I'm starting with and flips it. So what would that look like here? In this case, x to the -2 over 1, if I want to make that positive, I need to take this object and drop it down, or take its reciprocal and move it down into its opposite section. Okay, had it started in the bottom, I would move it up to the top. That's basically how it goes. So in this case, I'm going to still have a fraction, but in this case, it's going to be 1 over x now to the +2. That's what we learn about negative exponents. A negative exponent simply moves it into its reciprocal form. So x to the -2 is the equivalent of 1 over x to the +2. And that would be my final result here. It is fully simplified. I now have only positive exponents. There's the solution to problem number 2 on your final exam. So be prepared that you're going to be adding up exponents. If you get a negative result, wink, wink, hint, hint, you will get a negative result. Then you're going to be moving it into the denominator in order to get your final result. Okay, end of problem number 2. Problem number 3, you're going to be tasked with the same question. It's also going to be from section 4, so we're still dealing with our properties of exponents, okay? And you're still going to have to put it in only positive exponent form. But now we're going to be dealing with multiple properties being performed at once. So your problem on your exam will look similar to the following. Okay, you're going to see a fraction. Let me give myself a little room. You're going to see a fraction, numbers and letters. That fraction, the whole thing, is going to be raised to a negative exponent. And you're going to be asked to simplify this phrase using only positive exponents. So let me walk you through a process here. There are going to be a few different exponential properties that are going to be applied in this case. Okay, first things first. The easiest thing to do here would be to deal with my positive exponents at the very beginning of this. It will save me a lot of work and hassle towards the end. So the very first thing I want to deal with is the fact that I have a negative exponent. What I'm going to do here is I want to make this a positive exponent. And again, we're going to deal with the concept of taking a reciprocal. But the difference here is that I have a whole fraction raised to a negative exponent rather than just like an element, a piece, like just the numerator or just the denominator. Since the whole fraction is raised to a negative exponent, the whole fraction is taken in its reciprocal. So 4 over 3x is going to become 3x over 4. And now that I've taken that reciprocal, that negative exponent becomes positive. Okay, so step 1, you will see a negative exponent on problem number 3 of your final. The simple solution here is to just take this fraction, flip it. My students before have called it a refliprical because it helps with that word, that key term. Okay, but you're going to get to this result where you simply have flipped your fraction, and now I have a positive exponent. The value there is that now whatever happens in this case, I'll be dealing with only positive exponents. So it takes out that piece of work right at the beginning. Okay, but now I need to start applying the other properties going on here. Let me give myself a little room. There we go. Okay, so now I need to deal with the simplification process, basically reducing this down. This exponent, and you will not necessarily see an exponent of 2 on your final. Okay, it could be a 3, it could be a 5, it could be a 9. Okay, it doesn't matter. Right? Whatever exponent is here, essentially what we're going to do is we're going to distribute this exponent throughout the objects inside of this parentheses. And technically, there are 3 different objects inside this parentheses. There's a 3, an x, and a 4 in the denominator. Each of these objects is going to be raised to this power, whatever power you end up having on your final. So in this case, what I'm going to be doing is I'm going to be distributing that exponent throughout these objects, and I'll get the following. The 3 objects are as follows: 3x, and then the denominator 4. Each of those objects, and notice that each of the 3 and the x in the numerator are both going to get that exponent. In this case, it happens to be a 2. On your final exam, it may be different. But that's the process of distributing that exponent. That's one of the properties of exponents right there. Okay, at this point, what I would now do is that anything that can be reduced further, I want to reduce, namely this 3 squared, that's an actual number. This 4 squared is also an actual number. The x squared I won't be able to do anything with. That's going to stay x squared because it's a variable. I don't know what it is. It's an unknown. So when I perform this, the x squared is going to stay x squared. And it's still a fraction. 3 squared, or 3 times 3, will turn into 9. And then in the denominator, 4 squared, or 4 times 4, will become 16. At this point, the last thing I would have to do is check if my fraction reduces in any way, shape, or form. It does not. And there's actually a quick way to check. At the very beginning of the problem, check to see if your fraction can reduce at all. 4 and 3, there's nothing in common that can reduce it any further, so those stay as they are. Since this can't reduce, that can't reduce, which means this can't reduce, which means that will not reduce. Particularly when it comes to exponents, if these factors don't reduce, exponents of those factors will also not reduce. In other words, this will be your final answer. Okay, it is fully simplified, and it is using only positive exponents. There's problem number 3 on your final exam. All right, let's keep going. One last problem to cover for chapter 1, and that'll be our last problem for this first recording. Scroll back up here. All right, the last problem from chapter 1 is going to be a reference from chapter 1, section 6. Chapter 1, section 6 dealt with exponential functions. Exponential functions. Exponential functions were our a times b to the x power type of functions. Okay, they're exponential because one of my variables is actually in the exponent place, thus the name exponential function. Okay, but how will you see this in your final exam? You will be given an exponential function. Now, what I'm going to be writing here will be different than what you have on your final exam, but you'll be interpreting it the same exact way that I go through in this problem. So let me write it in a different color so we can kind of understand that I'm dealing with something that will look different on my actual final. Okay, let me give you the following. Okay, this is an example of an exponential. I ran out of room. Hang on. It'll be the same numbers, but let me just move this over. I ran out of room. Shoot. All right. Let me write a little smaller. There we go. Okay. This is an exponential function. Okay. The y and the x, that's common because that's going to tell me I have coordinate points and that sort of thing. But here's where it's a times b to the x power. All right. This is what tells me it's an exponential function, the fact that one of my variables is in the exponent place, right? And with that, that means it's going to have a very definitive type of shape when I graph it and very definitive type of qualities, okay? And in this case, just to break down what we're looking at, if you recall from section 6, and again, if you need to see more of this, you can check out the recordings and resources, okay? A times b to the x power. This a does actually something to it visually and stuff, but it has an actual meaning. Whatever value ends up being here, this is essentially a starting amount for our exponential function. Graphically, it would be like a y-intercept in this case, where x equals 0. But this is like a starting amount. Whatever amount this may be representing, this is where it begins at 470. Okay, maybe it's money, maybe it's an amount of something, I don't know. Okay, the base of the exponent, b, okay, the base of this exponent, in this case 0.59, this represents what we call a constant factor or constant multiplier. In other words, this is where I begin. My very next value will be this beginning amount times that value. So my next value after 470 would be 470 times 0.59. Okay? And then the next value after that would also be multiplied by 0.59. And the next one after that would be multiplied by 0.59, so on and so forth. Okay, and that's where we're going to get, if we were graphing this, that's where we get the curve of that graph. Okay, and then also to put this into our instructions, whatever we're going to be dealing with, we're going to be rounding that result to the nearest hundredths place. So just to clarify, the hundredths place is 2 decimal places, or for instance, 0.59 would be an example of a decimal in the hundredths place, 2 decimal places. Okay, so this problem that you're going to get, problem number 4 on your final exam, is actually going to have 3 pieces to it, an A, B, and a C. Okay, don't worry, they're going to be pretty quick. So let's burn through them. Okay, so they're all going to be based on the function that you're given. Again, this one will be different for you on your final exam. So part A, you're going to be asked to do the following. You're going to be asked to determine whether this exponential function represents growth or decay. This is the equivalent in a linear function of asking whether or not it's a positive slope or a negative slope. Okay, and similar to a linear function, the actual process of determining that is just simply looking at a single number here. In this case, we're going to be looking at the base of our exponent, the constant multiplier. In this case, I just simply have to identify that number. In this case, it's 0.59. It will be different for you on your final exam. So whatever value is in that parentheses, that's what you're going to care about. In this case, 0.59. So what does this mean? How do I use this number to figure out whether it's growth or decay? In this case, it's going to end up being decay. Why? Decay would end up being my final answer, but you may be curious as to why it's decay. The fact that 0.59 is less than 1 is why it's decay. Okay, so let's think about that for a second. Had my constant multiplier been 1, then every time I multiply it by something, that'd be 1 times something, and 1 times anything keeps it exactly the same. So that would be an example of what we call a constant function. If my constant multiplier is less than 1, say for instance 470 times 0.59, 470 times 0.59 will quite obviously be less than 470, thus decaying or getting smaller. Had this number been bigger than 1, that would be an example of growth. Because anytime I multiply something by something bigger than 1, it's fundamentally getting bigger. Okay, and that's simply how you can determine growth versus decay. Be prepared for both. on your final exam, or I should say, be prepared for either on your final exam. Okay, so we're still going to use that same function for these next two pieces. All right, part B. We're also going to be analyzing that same exact value, the base of the exponent. Now we're going to be asked to identify a rate of growth or decay, depending on what result you got for that part A. Rate of growth or decay refers to how fast is that something growing or decaying. Pretty valuable piece of information, particularly when you think about something like disease. If it is an exponentially growing disease, you're going to be caring very, very closely about how fast it's growing or decaying. Okay, well, here's the same thing. I'm going to care about that same exact number, the base of my exponent, the constant multiplier, constant factor. In this case, 0.59. So how do I figure out the rate of growth or decay? Rate is going to imply that I'm going to deal with a percent. So let's figure out how to solve for that. Whatever the base of your exponent is, in this case, 0.59, you're going to subtract 1. Subtract 1. In this case, when I do that, I get the following value, negative 0.41. Makes sense because when I subtract 1 from something that's not quite 1, it makes sense I get a negative. All right, well, for the record, this negative just confirms the fact that this was, in fact, decaying. It is getting smaller every time. But how do I convert this into a percent? Here is where I'm going to use my conversion for a percentage, okay? In order to do that, I'm going to take this decimal place. I'm going to move it to the right 2 places. In this case, when I move it to the right 2 places, I get 41%. 41%. The negative just tells me it's 41% decay. Had it been growth, I would have gotten a positive decimal right there. But again, just take your base of the exponent, subtract 1, you'll get a decimal. Convert that decimal into a percent by moving the decimal twice. Part B, done. All right, last little piece here for this problem. Again, both of those were relatively quick. You just had to basically look at a number. Quick calculation there, I suppose. But part C, for part C, now you're going to be asked to solve for a given value. In this case, let's use x equals 3.27. All right, your number will be different on your final exam. Okay, but you're going to be asked to basically plug in this value for x, see what pops out the other side. In this case, that simply means I'm going to be substituting in 3.27 for x. So if I go back to my original function, y equals 470 times 0.59 to the x power, what would be x up here, I'm going to be replacing with that value, in this case, 3.27. Okay, so this is now my function. All of this can be done on the calculator. Really, the only thing I have to be careful of here is that I need to be aware of order of operations, PEMDAS. Well, in PEMDAS, the very first thing I need to worry about here, after parentheses, there's nothing to do inside of here, would be exponent. So in other words, I need to take this 0.59 and raise it to the 3.27 power. So pay attention to this. I'm going to show you how to do it on a calculator. Okay, so on your calculator, let me figure out a place I can do this. There we go. On your calculator, if I want to do 0.59 to the 3.27 power, I'm going to start with my base number, 0.59. Let me zoom in here so you can see the button I'm about to use. All of your scientific calculators will have this button, X, and you'll see a little Y power there, X to the Y power. That button allows you to customize an exponent. So let me refocus. Okay, so if I want to raise this to the 3.27 power, I'm going to press that button. It's now waiting for that exponent, 3.27. When I hit equals, it gives me a very gross decimal. Great. Okay, these are not friendly numbers. That's done on purpose, so you can't do it in your head. So when I've done 0.59 to the 3.27 power, I get the following. I get y equals, don't forget about that number out in front, that a value, 470. But now I'm going to get a gross decimal as a result of this exponent. In this case, 0.178109087. Now remember, I said round to the nearest hundredth or 2 decimal places. So if I round this number to 2 decimal places, that's 0.18. 0.18. So after that result, I have a simple multiplication problem, right? multiplication comes after E for exponent. So now I would do this piece. And when I do 470 times 0.018, you could either do the unrounded number and then round it after this fact, or I could do 0.18 times 470, and I would get 84.6. Rounded to the second decimal place would be 84.60, just to be 2 decimal places, right? That would be my final answer here. Technically, I've just created a coordinate point, 3.27, 84.60. But to solve that problem, when x is 3.27, y equals 84.60. And that will be the end of our first recording. All our problems from chapter 1 are now finished.